Okay, chapter 5 is all about polynomials, which quadratics are polynomials. They're extremely simple polynomials. Polynomials, different parts. A monomial, a real number, a variable, or the product of real numbers in one or more variables. It's one term, monomial. Binomial has two terms in it, either added or subtracted. X plus 2, 3x squared minus 5. Those are binomials. They got two terms. Trinomials have three terms, added or subtracted. A polynomial is anything more than three terms. One term's a monomial, two terms a binomial, third term's trinomial. Anything else we just call a polynomial because technically we can have an infinite number of terms. And you can't come up with special names for everything all the time. So we just do the first three because it is the most common. Okay. What is a term? Terms are all separated by plus or minus signs. The degree of a monomial is the exponent of the variable. So the exponent on the variable determines the degree of the monomial. Degree of a polynomial is the largest degree. It's the largest power. So when I have x squared, when I have a quadratic, all the quadratics, x squared plus 2x plus 3, it was degree 2 because the largest exponent was 2. Okay, largest exponent is degree. Standard form is where you arrange it by degree, largest to smallest. So you do your variable, largest power on down to the smallest power, where a constant where you don't have a variable is by itself on the end. Standard form. We want to try to put everything in standard form if at all possible. Okay, so example problem number 1, classify each by name, degree, number of terms, and put in standard form. It's actually putting it in standard form should be the first thing you do. So if I put this one in standard form, I get negative 7x squared plus 3x plus 6. Okay, by name, it is this is a quadratic because it has a degree 2. Has a degree 2, which makes it a quadratic. Okay. And how many terms do we have? We have 3, so this is a trinomial. Okay, largest degree is 2. Standard form, largest power, next one down. Be careful with the negatives. That's what students tend to lose when they rearrange them, particularly if it's a minus like that when I have minus 7x squared. The negative in front of the 7x squared needs to move with it up to the front. Don't lose it because you move it. Okay, second one's actually pretty easy. What's my degree? What's the largest power? 5. So this has a degree of 5. Because that's the largest power. It's only one term, so it's a monomial. And we don't have any special name for it based upon its degree. Okay. So the next one we want to rearrange. And in this one, we want to combine up like terms too. So my highest power is b to the 5th. So that means I have negative 7b to the 5th. Cross that out. And then I start looking, what else do I have? Do I have any b's to the 4th? No, so I don't have to worry about that. Do I have any b cubes? Yeah, I've got 2 of them. I've got 6 here and minus 5 here. So how many b cubes do I have? I have 1. I had 6. I took away 5. I've got 1. 6 minus 5 is 1. And then I look at what's left. Okay, then I got b squared. I have minus 2b squared. And then I have plus 3b. And I don't have anything else. Standard form. Combine up like terms. Largest power to smallest power. What's my degree? 5. Largest power, so that's degree 5. And I don't have any special names for that. We didn't really discuss that. But a degree 1 is linear. Straight lines are degree 1, x to the first power. That's what they are. Degree 2 are quadratics. Degree 3 are cubics. Anything higher than that, we have no special names for at all. And then, how many terms do I have? I've got 4 terms. It's more than 3. It's a polynomial. And technically, monomials and binomials and trinomials are also polynomials, but because they have a specific number of terms that count, we have special names for them. But technically, they're all polynomials. But we stop giving them special names when they get larger than 3. Your turn. Put them in standard form, name the degree, and if they have any special names that go with them, do that as well. Okay, so on the first one here, y squared is my largest power. I've got 9 minus 1, so I have 8y squared. And then minus 3y plus 5. This has a degree 2, which makes it a quadratic. And oops, that's not a K on the quadratic, it just ends with a C, my bad. And then it is a trinomial.
Wait, what's the quad?
It's a quadratic because it's x squared, so we call it a quadratic.
Okay. Do we have to put that down on the test?
No, but you should know it. It's one of those things. If it's first degree, it's a linear equation. You should know, be able to recognize a linear equation.
So
Okay, you should know and recognize what a quadratic looks like. Ooh, I have x squared is my largest power. There are certain things about quadratics that aren't true for anything else.
So anything that is x squared for the first.
Yeah, if it's a degree 2, x squared, it's a quadratic.
Okay. All right.
Which means it's a parabola, which means it has symmetry, all kinds of stuff that goes with that. That's what we spent the entire chapter 4 on, was nothing but quadratics, a particular type of polynomial. And before that, we all worked with linear, which is also a particular type of polynomial. Okay. So this one here, I have 6n cubed, 6n cubed, and then I have n squared and an n squared. 3n squared minus 1n squared gives me 2n squared, and then negative 5n, and then plus 2. This has a degree of 3. Okay. And this is one we haven't really talked about, but a degree of 3 is a cubic. Because the largest power is a cube. Okay. So we call it a cubic equation because n cubed is the largest one. These, by the way, although you don't need to really know it, the graphs, the ones that look like that, they have this disco thing going on. Okay, that's what they look like. Or they look like this if they're negative. This way if they're positive, this way if they're negative. That's what they look like. And then it has how many terms? 4 terms. So we call this a polynomial. And then the last one, can't rearrange it. It has a degree of 4. It is a monomial, and we don't have any special name based upon the degree. The only ones we have special names for based on the degree, linear equations, quadratic equations, and cubic equations. Everything else, when it starts getting larger than 3, we don't have special names for anything larger than 3. We just call them a polynomial and call it good. No. You should have them in alphabetical order. If you have more than one variable, it's in alphabetical order. And that's a good aside to have. If I have more than one variable, it's in alphabetical order. And it's the largest one, largest power of that first variable goes first. So if I have more than one term, let's say I have x's and y's together. If I have an x squared and a y, x goes first. I put that in standard form first. And then the y's fall where they may. It's always alphabetical order, largest power of the one that's alphabetical first. So I take care of, if I have several terms that have both x's and y's in them, I do x comes first, and the highest power of x determines its order, and then if I have no terms with x's and y's only, then they get tagged on at the end. That's standard form. You don't rearrange the variables. Variables are always, should always be in alphabetical order. Always be in alphabetical order no matter what. And that, dear ladies and gentlemen, is probably one of the shortest sections you will ever have in this class. But it's not, just because it's short doesn't mean it's not important. The idea of, I can stand up here and say, oh, we have a binomial quadratic, you should understand what I'm talking about. Oh, it's two terms of the highest power of 2. You should be able to use the terminology and have you understand. If I write a test question, you know, give me an example of a trinomial quadratic. You better be able to know, oh, that's 3 terms, and the highest power is 2. So I've got to be able to have x squared and an x and a constant and be able to give me that. If I were to do that as a test question, you've got to understand the terminology. You've got to understand the language. Math has its own language. You have to understand the language that we talk about, that I use, in order to be able to do this. Okay?